Data preparation remains the foundation of reliable results. Even in SQL, quality, partitioning, and feature selection determine model strength. Partitioning large tables by date or region ensures efficient training and avoids bias toward recent or dominant data. Feature engineering transforms raw columns into meaningful signals, like ratios or lagged values. Leakage, when information from the target variable leaks into predictors, can still occur if joins or derived features use future data. For example, calculating revenue growth using the current quarter when predicting the same quarter's sales inflates accuracy unrealistically. By validating partitions and time logic, teams keep training realistic and predictive. BigQuery ML simplifies data access, but it still rewards rigor in preparation and validation. The create model command defines everything about a model's purpose, structure, and behavior. Users specify options such as model type, target column, input features, and hyperparameters, all in one statement. For example, a regression model predicting sales might use create model, myDataset.SalesModel, options, model type, linear reg, as select star from training data. Additional options control regularization, early stopping, and learning rates. BigQuery ML handles scaling automatically, allocating compute resources based on data size. This declarative approach turns machine learning into an extension of data management. You describe what you want, and the platform does the rest. Create Model democratizes model creation, transforming SQL scripts into predictive assets ready for evaluation and deployment. Training costs in BigQuery ML depend on data volume, model complexity, and reservation setup. Because training runs inside the BigQuery engine, billing follows standard query pricing or uses allocated slots if you have reservations. Large-scale training can consume substantial compute resources, so cost awareness matters. Teams can estimate expense by sampling subsets before scaling full runs. Reservation planning ensures predictable performance. Dedicated slots eliminate contention during heavy workloads. For instance, an organization running nightly model refreshes might reserve capacity to guarantee consistency and prevent queue delays. Cost efficiency grows through iteration. Test on smaller datasets, optimize features, and retrain only as needed. BigQuery ML's integration with billing and monitoring tools makes these optimizations straightforward and transparent. Evaluating model performance with ML.evaluate provides clear metrics for decision-making. This function outputs standard measures such as accuracy, precision, recall, and area under the curve for classification, or mean absolute error and R-squared for regression. These metrics quantify how well the model generalizes to unseen data. For example, an e-commerce analyst predicting customer lifetime value can compare model versions by their mean squared error directly in a query result table. The evaluation step encourages evidence-based iteration, keeping the focus on measurable improvement rather than assumptions. By storing evaluation outputs within BigQuery, teams can track performance history alongside the data that trained the model, reinforcing governance and reproducibility. Predictions are made with ML.predict, which applies trained models to new data in place. This function produces output tables with predicted values, probabilities, or classifications. For example, a bank can run ML.predict on recent applications to estimate default risk scores, all within the same dataset. Predictions can feed dashboards, trigger alerts, or drive downstream workflows. Because the process uses standard SQL, predictions scale automatically with table size. Batch scoring becomes as simple as querying a view. Integration with scheduling tools allows routine updates, ensuring insights remain current. ML.predict exemplifies BigQuery ML's core strength, turning predictive modeling into an operational habit instead of an isolated experiment. Explainability in BigQuery ML uses feature attribution to show which inputs influence predictions most strongly. Functions like ML.explainWeights return feature importance values for linear and boosted tree models, while ML.globalExplain summarizes global trends across the dataset. These insights reveal how models think, supporting auditability and trust. For example, in a churn model, seeing that recent support interactions and contract duration carry the highest weights helps managers validate logic and refine strategy. Feature attribution also aids fairness analysis by detecting unintended dependencies. Transparency turns black boxes into glass boxes, models that can be examined, debated, and improved collaboratively. BigQuery ML's explainability tools make accountability part of the workflow, not an afterthought. Time series forecasting in BigQuery ML leverages ARIMA Plus models, an enhanced version of the classical autoregressive integrated moving average method. These models handle trends, seasonal patterns, and outliers automatically. Users can specify forecast horizons and confidence intervals directly in SQL. For example, a retailer might forecast monthly sales per region for the next year with a single create model statement. ARIMA Plus adapts to changing trends without manual parameter tuning. The simplicity hides sophisticated internal logic that balances accuracy and computational efficiency. This capability means that forecasting, once the domain of specialized statisticians, can now be part of everyday analytics, empowering business teams to project outcomes quickly and adjust operations proactively. Recommendation systems in BigQuery ML use matrix factorization to predict user preferences. This method decomposes large interaction tables, such as user product ratings, into latent factors that reveal hidden affinities. For instance, an online learning platform can recommend courses to students based on patterns shared by similar learners. Matrix factorization models are trained with a few lines of SQL and scale automatically to millions of interactions. Evaluation metrics like mean average precision guide tuning. The combination of ease and power makes recommendation building accessible to analysts who once needed specialized environments. By hosting data, training, and prediction in one place, BigQuery ML removes the friction between insight and implementation in personalization projects. Governance in BigQuery ML ensures that models remain secure, reproducible, and compliant. Access controls managed through identity and access management define who can create, view, or execute models. Lineage tracking links models to datasets and queries, maintaining transparency over inputs and transformations. Reproducibility is guaranteed by storing model definitions, training parameters, and evaluation results directly in BigQuery tables. For example, auditors can trace a prediction back to the model version and data snapshot that generated it. Integration with audit logs and cloud monitoring adds operational assurance. Governance in BigQuery ML is not an extra step, it is built into the platform's architecture, ensuring that speed never compromises accountability. Common business use cases illustrate the platform's practical range. Marketing teams use logistic regression to predict campaign responders. Finance groups use linear regression for credit risk, and supply planners rely on time series forecasting for inventory. Retailers generate recommendations, media platforms classify content, and support departments automate sentiment analysis. What unites these examples is accessibility. No external pipelines or custom code. The models live with the data, run at scale, and align with existing analytics workflows. The simplicity lowers barriers, allowing small teams to achieve outcomes once reserved for large data science divisions. BigQuery ML brings prediction to the front line, where questions and decisions intersect. BigQuery ML delivers fast insights with minimal friction by merging analytics and machine learning into one system. It removes the barriers between data storage, modeling, and deployment, letting teams experiment and act in real time. This SQL-first approach aligns technology with human skill, governance with agility, and prediction with practicality. By working where data already resides, BigQuery ML reduces latency, increases trust, and democratizes intelligence. When organizations use it responsibly, with clean data, clear objectives, and consistent validation, they turn everyday queries into predictive power. BigQuery ML shows that the shortest path to insight is often the simplest one. Models built directly inside the warehouse, ready to inform the next decision immediately. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.